In this video, we will see briefly what gains are and how they can be used in finance. In today's finance, machine learning and artificial intelligence became the big deal, and it is important to be able to master some models and their application to be able to fully understand the problematic that you can encounter as a worker in the field of finance. This video will not be heavy in mathematics. The goal is to understand the concept of gain and how they are applied to finance. Firstly, I will present the idea behind the gains. What is the goal behind the structure, how they are constructed, and how they are used. And in a second part, I will present real projects that are used or studied by investment banks, fintech companies, or even financial regulators. First, let's understand what gains are. GAN is the acronym for Generative Adversarial Network. They are a certain type of neural network architecture created by Ian Goodfellow in 2014. The philosophy of this model is to put two neural networks in competition in a game. At each round of the game, both neural networks are learning from their mistakes. The following scheme shows how does the GAN work. The two neural networks mentioned are the generator, whose the goal is to create datas that are similar to the one provided by the scientist, and the discriminator, which is a classifier which has to classify as real or fake the datas that are provided. The game they are playing is as follows. The generator creates data whose aim is to resemble the scientist's data as closely as possible. Then the discriminator is then supplied with real data and data created by the generator and has to classify them. If the data created by the generator is classified as fake, then the generator loses this round and adjusts its parameters in order to create more realistic datas. If it is classified as real, then the generator wins the round, and the discriminator adjusts its parameters to be more accurate during the future rounds. In reality, the training of the neural networks are not done simultaneously, but one after the other. As you can understand from this introduction, GANs are very powerful tools, whether for generating data or detecting anomalies. In fact, once the network has been trained, we have two well-trained neural networks. One is capable of generating data that is almost indistinguishable from real data, and the other is capable of detecting the slightest anomaly in the data it is given and is able to indicate whether the data is real or not. With tools like these, it's easy to imagine applications to market finance, and in fact, a lot of researchers are studying these models in order to fine-tune them to finance. In the academic literature, GANs became pretty popular during the past years and has emerged as a powerful tool in finance, enabling to have a different approach to complex problems. The application of GANs are multiples, and 4 of them will be presented here, but we can imagine many other applications. The first important application of GANs in finance is time series generation. For this first application, the goal is to be able to generate datas that look like real financial time series. Once the model is trained with market time series datas, the generator is able to create datas that respect some stylized facts of financial time series. I would like to emphasize on the fact that generating financial time series is not the same as generating climate, macroeconomics, biological, or even physical time series. As stated before, there are some stylized facts about the financial time series that distinguish them from other time series. These nuances can sometimes be subtle and a little technical, but you need to be aware of the subtlety of the properties specific to financial time series. In fact, researchers and market experts have long been aware of the special properties of financial time series. These properties are stylized facts that are observable on financial data. The most important properties are the absence of autocorrelation, fat tail distribution, volatility clustering, gain and loss asymmetry, volume and volatility correlation, and there are many more stylized that can be observed. Obviously, it exists many more properties that characterize financial time series. It is therefore very difficult to create a theoretical model that takes into account so many stylized facts. Some models try to take into account as many of these features as possible, such as GARCH models and their derivatives, whose the goal is to model volatilities of assets. All the well-known econometric models, although complex, are unable to fully describe the complexity of financial data. One way of alleviating this problem is to use neural networks, which take into account millions or even billions of parameters, and therefore capture features more accurately. But as you know, with great power comes great responsibility, and it can be very tricky to calibrate or train such models. But for the purpose of generating time series, GANs are widely studied. Another use is portfolio management, where a GAN model is used to optimize the allocation in the portfolio. They can be used by generating market scenario for stress tests in order to evaluate the performance of the portfolio in different situations. It can also be used to compare real market data and generated data of the model to detect anomalies in prices or returns, and consequently investing in or divesting from an asset or a stock. The third common use of GANs is for time series forecasting. Here, unlike the first point, we don't want to create 100% new data, but to predict and extend our current data. The aim is to be able to make market predictions and, above all, fine-tune trading models. By generating consistent future data based on the properties of historical data and not just random generations, we can greatly improve our models. The last use is the fraud detection. In the first point, we focus on the generator of the GAN, but the discriminator can also be used as a powerful tool. As stated before, GANs are able to learn historical data's pattern, and therefore transaction patterns. We can use this feature of the model to detect market manipulation or to detect credit card fraud. To do so, we use the discriminator of the model and compare the generated datas and the live datas in order to detect abnormal market situations. As we see in those examples, GANs are very versatile and cover a wide range of problems and are now a crucial tool to understand. Now that we understand what are the theoretical use of these models, we can wonder, are these models really used in practice? Because training such models can be very complicated and require a lot of resources. The answer to this question is that even if they are not widely deployed in investment banks, hedge funds, or fintechs, a lot of money is invested into it and many hopes are placed in them. But to be clearer, let's take real case uses to understand how GANs are really used by professionals of finance. Concerning investment banking, the bank that is well known to invest in generative data is JP Morgan. As a proof, JP Morgan released in February 2024 an article that presents what are their thoughts on generative AI and their use in the next 15 years. JP Morgan estimates that generative AI could increase global GDP by $7 to $10 trillion in the next decades. It also states that this technology could result in a massive workforce productivity that will boom in the next 1 to 3 years, which could affect the shape and the dynamics of the economic cycle. A lot of money is invested into GAN, and JP's AI research department has a branch dedicated to generating synthetic data. The goals of this department is, for example, to provide synthetic data to other teams and detect credit card fraud. But not only investment banks invest in GAN models, as stated before, GANs can be used for time series generation and fraud detection, and we will see two more examples: the Financial Conduct Authority and American Express. First, the Financial Conduct Authority is a financial regulatory body in the United Kingdom. It developed an environment called the Digital Sandbox, whose the goal is to provide an environment where it is possible to test financial models and perform stress tests. The overall goal is to improve the financial resilience of vulnerable consumers and develop fraud detection. The whole project heavily relies on synthetic data that are generated by GANs and agent-based models. As you see, even regulators and states are considering to use such algorithms in the future. Another company that invested in GANs is American Express. American Express being one of the biggest financial companies and credit card provider, it is subject to massive loss due to credit and debit card fraud. To solve this problem, American Express invested in GANs in order to detect more efficiently frauds. Currently, companies like American Express that have to deal with frauds problem are using their customer real data to train their model and prevent fraud. The problem with training fraud detection models on real-world data is a problem called class imbalance. To make it simple, the goal of the model is to take in input information about transactions and classify it as a legitimate or a fraudulent transaction. But the major problem when you train with real-world data of customer is that the data labeled as fraudulent are only the detected fraud. It means that the number fraud is underestimated in the data set because the company is not already able to detect all the frauds, and in addition, data labeled as legitimate in the data set are in reality undetected frauds. With such misleading data, the fraud detection models are not already able to detect fraud efficiently when they are trained with real-world data, because the real-world dataset do not permit the model to understand the pattern of a fraud due to class imbalance problem. To solve this problem, American Express decided to invest in the development of GANs to generate simulated dataset on which you trained your fraud detection models in order to be more efficient too than real-world data's trained models. Unfortunately, for the moment, American Express released the first results of their experiments and GANs-trained models underperformed the models trained on real-world data, but they also indicated that they are still working on this data to improve their models. As show this last example of American Express, GANs are not a miracle solution that can solve your problem miraculously. GANs have pros and cons like all the other models, but it is interesting to keep digging into these models. Even if it does not work today, a lot of researchers are investing time and money into it because they see a real potential in this kind of models. To sum up what we saw on this video, GANs are composed with two neural networks. On one side, we have the generator, whose job is to create synthetic data samples, such as images, music, or text, that closely resemble real data. On the other side, we have the discriminator, whose task is to differentiate between real data and the fake data generated by the generator. Now, here's where the magic happens. The generator starts by producing random samples, which are then evaluated by the discriminator. Through an iterative process of trial and error, the generator refines its output to produce samples that become increasingly difficult for the discriminator to distinguish from real data. Meanwhile, the discriminator is continually improving its ability to spot fakes. This dynamic interplay between the two networks leads to a scenario where the generator becomes exceptionally skilled at creating realistic data, while the discriminator becomes adept at identifying even the subtlest of discrepancies. As we see, big investment banks and fintech companies are investing on it, and GANs will definitely be a big deal in the following years.